Hey there, class. We're going to look at the, just give you some insight into problem number 12 from our homework here. So I'm going to actually scroll down to where I've done a little bit of work for that. So the first thing that we could kind of take a look at here, first of all, when we take a look at number 12, there's a couple different ways you can kind of approach this. So one way we can approach this is that if we take a snapshot of when these guys are together here, this is when they're at the same place at the same time. Okay, now the trick with this is that this guy actually waits 3 seconds before he begins to accelerate. So what we have to account for is the fact that there will be a 3-second delay before he begins to actually accelerate. Now what happens here is that during this time interval that they're both moving, they're going to both travel the same distance. So that's kind of the key ideas here when it comes to solving it this way. We know that they're going to both travel the same displacement, or they're going to travel the same distance, but the important thing here to remember is that the time for the first guy is going to be actually 3 seconds less than the second skater. And again, that's because this guy has a 3-second delay, so we have to subtract 3 seconds off of this guy who's moving longer. But basically the rest of the approach here is actually going to be very similar in both ways that I'm going to show you. But pretty much the idea is we want to figure out an equation that relates their distances with their times that they're traveling. And this equation for skater 1 who is accelerating, again, I need to make sure that I pick one that shows acceleration here. Since the other one is not accelerating, I can actually use this equation that doesn't require acceleration. Now, ultimately, what we're going to do is we're going to use the equations here. We're going to set them equal. And what I do is I actually do that over here. I set this one equal to that one, where this comes from right here, and this comes from here after I've solved it right there. Now, from this point forward, really, it's just algebra. So I'm not going to go through every little detail here. Of course, you can actually see this solution in the Notability folder. So I'm going to kind of stop, and I'm going to look at our second way to think about this here in just a moment. So the second way to think about this is by thinking about making the times that they move equivalent. So in our first way of thinking about it, we had them moving the same distance. But in this case, we're going to actually have them move through the same amount of time. And the trick with this is that whenever this guy begins to actually start to skate, in other words, when he starts to accelerate, this guy right here, skater number 2, will have already moved past the point. Okay, so this is kind of like the delay time. If you've watched any of my other videos on the examples, you'll notice there's a delay time where this thing is actually moving there. So the keys on this one is going to be where the times are actually equivalent, but the difference here is that because the second skater travels this extra distance during the delay time here is 3 seconds, then the distance that he is moving during this time interval is going to actually be less than the other guy. So that's why we have to subtract the 36 meters, which is how far he travels in that time interval. But aside from that, the approach is actually pretty much exactly the same. We're going to use the same 2 equations. We're going to do the same kind of steps here. The difference here is that, again, since time is equivalent, you're going to make these substitutions for time. And again, from this point forward, it really just becomes an algebra thing. One note to take out of this is that it actually does come down to using a quadratic formula to actually solve this for the desired quantity. So just wanted to do that, show you guys a little bit of the science behind it, the physics behind it. Of course, I'm not taking through all the math details. You can look at that on your own time to see my solution there. Hopefully that helps.